In this lesson, we are going to create a C-axis cross-contour toolpath and discuss C-axis toolpaths. C-axis toolpaths are unique to lathe. They are a simplified version of our milling toolpaths. The benefit of using them is they apply the necessary plane for the toolpath being created. Full milling capability is available in lathe with a license. However, the proper plane needs to be selected or created, as with any mill toolpath. Which toolpath to use when both are available depends on the situation or the comfort of the programmer. On this part here, we're going to start by creating a toolpath for this flat over here, and we'll use the geometry at the intersection of the flat and this face right here. There are two contour toolpaths in the C-axis group. There's the C-axis contour and there's the C-axis cross-contour toolpath. The C-axis contour is for any geometry that is located about the axis of rotation. The tool will not move in the Y-axis. Only the C-axis moves. The cross-contour op utilizes the Y-axis on the machine turret, which allows the cut to come across the part. So if we pick the edge of the flat on our geometry, right here, you can see where we need to use the Y-axis on our machine. When the Y-axis is used, the spindle is typically locked in place with the C-axis. Keep in mind that not all machines have C or Y-axis and live tooling. So let's go ahead and make a tool path. I'm going to select the cross-contour op. I'm in solid chaining. I have single edges selected here. I'm going to come over, I'm going to grab this edge here down at the bottom so that the arrow points away from this corner here. For a tool, I'm going to grab T4, the 1/4 inch cross mill. I'll go ahead and put a comment in here. For our holder, live holders typically use an ER collet. Our default holder will give us a realistic representation of that. In our cut parameters, for our compensation type, I'm going to use the computer. And in our compensation direction, the arrow represents the geometry and the circle represents the tool. The picture accurately shows which side of the geometry and the direction the tool will cut. And I'm not going to leave any materials on the walls or the floors. We'll go to lead in, lead out, and I'll turn this on. I want my lead in to be tangent. I don't need or want any radius. I believe 80% of my tool will be enough, and I'll propagate those over to the right side. I do want to add some multi-passes. The tool's not big enough to make the cut all at once. So we'll add 4 of these. We'll space them at 150 thousandths. We'll make 1 finish pass, and we'll leave 20 thousandths for the finish pass. We will do a zigzag pattern. This will machine in both climb and conventional machining. This will allow us to keep the tool down. For linking parameters, we don't need any clearance, we don't need any retract, and we don't need any feed plane. We're just going to bring it down. If we take a look at our planes, you can see that it created a cross upper left top, or that plane already existed. For our axis control, we are going to use our left upper, and we are going to use our Y-axis in our rotary axis control. So I'll green check out of there. And let's take a look at our tool path. Let's go ahead and backplot that. So our tool comes right down next to the part. And then we go right in and come across it. We do a U-move and come back across it. So there's our C-axis cross-contour toolpath.